So hello my dear students. Now coming to the next topic under Boolean expressions, how to find shorthand min-term notation. As we have seen in the previous classes that min-term shorthand notation means we are going to show in terms of lowercase m. If we want to show the shorthand min-term designation for max term, we show it as the capital M. Now for example, if just the term is given, what are the steps involved to find out the shorthand notation or the min-term or max term designations? So here are the steps. To form shorthand min-term notation, following steps are to be followed. First one, it says copy the original term. Next, substitute zeros for barred literals, that is complemented form, and ones for non-barred literals, that is original form. Then it says express the decimal equivalent of binary as subscript of m. This is for min-term designations. Okay. So now let us take an example and check how exactly we are going to get it. Find min-term designation of, it says x, y complement, z complement. So according to this, what is the first step? It says copy the original term. So we have taken the original term x, y complement, z complement. Next, it says substitute zeros for barred literals, ones for non-barred literals. So here you have x, it is non-barred, so write 1. It is a barred literal, so write 0 and 0 for y complement and z complement. Next, we have to express decimal equivalent. How do you convert a binary value into a decimal form? As you have seen in your first PUC, you are going to multiply with powers of 2. So take 1 0 0, this become 2 raised to 0, 2 raised to 1, 2 raised to 2. So it is 1 into 2 raised to 2 plus 0 into 2 raised to 1 plus 0 into 2 raised to 0. So 1 into 2 raised to 2 is 4 plus 0 into 2 plus 0 into 1. So it is 4 plus 0 plus 0 returns 0. So for x, y complement, z complement, its shorthand or min-term designation will be lowercase m with subscript here as 4. Okay. So this is how we find the min-term designations for given min-term. Let us take another example which says a, b complement, c, d complement. So according to the steps given, let's start. First it says copy original terms. So we are taking a, b complement, c, d complement here. Then it says we have to give zeros for barred literals and 1 for non-barred. So a, it is non-barred, so write 1, b is complement 0, c is non-barred, it is 1, d is again barred, so we are going to put it with 0 here. Next, this binary value has to be expressed in terms of decimal form. So it is 1 0 1 0. So take powers of 2, 2 raised to 0, 2 raised to 1, 2 raised to 2, 2 raised to 3 here. Now convert. Take 1 into 2 raised to 3 plus 0 into 2 raised to 2 plus 1 into 2 raised to 1 plus 0 into 2 raised to 0. Next, 1 into 2 raised to 3 results in 8. So it is 8. 0 into any value results in 0. 2 raised to 1 is 2. 0 into value results in 0. So it is 8 plus 0 plus 2 plus 0 is 10. Therefore, the min-term designation for a, b complement, c, d complement is lowercase m with subscript 10. So these are the steps using which we can find the min-term designation for the given min-term. Now coming to the next one, which says shorthand max term notations. Now, how to convert or how to get the shorthand max term designation or notation. So here are the steps which says first, copy original terms. Now it says substitute zeros for non-barred literals. Non-barred means original. And ones for barred literals. Barred means complemented form. Next, Express the decimal equivalent of binary as subscript of capital M. For max term we are using uppercase M, and for min term we use lowercase m. Now let's take an example. So here you have x complement plus y plus z. We have to find its max term designation. So what steps it says? It says copy original term. So first take the original term here. It says x complement plus y plus z. Next, what it says? 0 should be for original term and 1 should be for complemented. So here you are having x complement, so you replace it with 1. You are having original term y, give it 0. Original term z, give it 0. Now we are using the same steps, converting this binary into decimal form. Take powers of 2. 2 raised to 0, 2 raised to 1, 2 raised to 2. So now it is 1 into 2 raised to 2 plus 0 into 2 raised to 1 plus 0 into 2 raised to 0. So now 1 into 4 plus 0 into 2 plus 0 into 1. So now 4 plus 0 plus 0 results in 4. So the max term designation for x complement plus y plus z is uppercase M with subscript 4 here. Okay. I hope you are clear how to get the shorthand max term designation notation. Let us take one more example. It says a complement plus b complement plus c plus d. Now according to the steps, take first original term. Now we have to substitute them. If it is complemented, we are substituting with 1. So b complement 1. C, it is non-barred, so we are putting 0. D is also non-barred, we are putting 0 here. Now again multiply with powers of 2. So it is 1 into 2 cube plus 1 into 2 raised to 2 plus 0 into 2 raised to 1 plus 0 into 2 raised to 0. So 1 into 2 raised to 3 is 8 plus 1 into 2 raised to 2 is 4 plus 0 plus 0. So it is 8 plus 4 results in 12. Therefore, the max term designation for a complement plus b complement plus c plus d results in uppercase M with subscript 12. So these are the steps involved in finding the min term and max term designations. Okay. So students, I hope you are clear with finding out the min term and max term designation of given min terms and max terms. Now moving on to the next concept, which is canonical expressions. Now what is meant by these canonical expressions? It says canonical expression is expression or a Boolean expression composed or made up of entirely, it should be either min terms or max terms, which means a given expression it should either contain all as min terms or it should contain all as max terms. Okay. So under canonical expressions we can represent in two types, that is sum of products and product of sum. Sum of products means here it involves all min terms. Product of sum means it involves max terms. Okay. So now first let us see what is sum of products. So it says when a Boolean expression is represented purely as sum of min terms. What is a min term? It is product of all the literals present in the given expression. So it should be represented as sum of min terms, then it is said to be in canonical sum of product form. Okay. If an expression is completely made up of only min terms, then it is called as sum of products. So you can see the example, you have xyz, x complement, yz complement, xyz complement. So here in this entire expression we are having three literals xyz, and you check each term. Each term consists of all the three literals and it is product. So if it is product of all the literals, these are min terms. Since sum is there for these min terms, it says purely as sum of min terms. So it is sum of products form. Okay. Now let's see what is product of sum form. What it says, when a Boolean expression is represented purely as product of max terms. So now let us first take this example. In this entire example, if you observe, there are three literals. Again, x, y, z. And you just see these three terms. Okay. In all the three terms, you are finding all the three literals which are present in the expression. Since they are sum of all the literals. So what is max term? Max term is nothing but sum of all the literals. So here all the three terms, all the three literals are there and they are represented as sum. So these are max terms. And these three max terms are represented as product. So it says, if a given Boolean expression is represented purely as product of max terms, that is said to be in canonical product of sum form. So I think students are clear what is meant by a canonical expression. It is a Boolean expression which should be either made of entirely min term or entirely of max term. So under canonical expressions there are two types. You have sum of products and product of sum. Sum of product means Boolean expression which is represented purely as sum of min terms. So it can be said as canonical sum of product form. Product of sum means it is represented purely as product of max term. So it can be said as canonical product of sum form. Okay. Now let us take an example of how to convert a Boolean expression or a function into canonical sum of product form. So to get a sum of product form, the first condition is we should have a complete min term expression. And we already know how to get a min term expression. Now let's take an example. First one. So it says x plus xy whole complement. Now let's take this entire expression. In this expression we are having two literals, x and y. Let us take the first term. Here y is missing, whereas in the second term both the literals are present. Now how to get a min term expression? As we have seen, we have to multiply with the missing term plus complement of that missing term. So let's take x, take y plus y complement plus xy complement, the second term. Now multiply, remove the bracket, xy plus xy complement plus xy complement. Now we should check whether there is any duplicate term. Yes, we have xy complement. So remove the duplicate term and write the final expression. So you have xy plus xy complement. Okay. So this becomes a sum of products form. Okay. Now each min term can be expressed as the min term designation or shorthand notation. Correct? So now if I am taking x and y, for min term, if it is a original term, which means they are holding value 1, as we have seen in the truth table for min terms. Next, if we are having a min term where there is a complemented form, then it is holding 0. So it is 1, 0. Now these are binary forms. 1 and 1 is the binary form for decimal value 3. How do you identify this? You already know how to convert the decimal into binary. 3 you have to divide by 2. So 2 ones are 1 is remaining. So what you get? 1 and 1. So 1 and 1 is the binary equivalent for decimal 3. So I have taken lowercase m with 3 here. Similarly you take 2. So you have 2 ones are, remainder is 0. So it is 1 0. So 1 0 is a binary equivalent for the decimal 2. So I have taken m3 plus m2. So we write the final function in the shorthand form as function of x and y, because x and y are the two literals here, equals summation is the symbol used for sum of products form. Into bracket you have these two decimal values. So 2, 3. You have to write it in the ascending order of the terms. So this is how we convert the given Boolean expression into canonical sum of products form. Now Let us take one more example. Convert the given Boolean function x plus y complement z into canonical sum of products form. So here is the example. You have x plus y complement z. Now if you carefully observe that expression, in that expression you are having three literals, x, y, z. Okay. So let's take the first term, x. Here there are two literals missing, y and z. Let us take the second term. Here there is one literal missing, that is x. So if there are, as I have explained while expansion of min-term expressions, if there are more than one term missing, then it is always better that we are going to multiply with one missing term at a time. So let's take first x. First we are going to get the first missing term here, that is y. So it says y plus y complement plus y complement z, only x is missing, take x plus x complement. Next, multiply xy plus xy complement plus xy complement z plus x complement y complement z. Still we don't get a complete min-term expression because in these two terms z is missing. Now multiply them, xy into z plus z complement plus, you are going to take again xy complement into z plus z complement plus xy complement z plus x complement y complement z. Now multiply, you get xyz plus xyz complement plus xy complement z plus xy complement z complement plus xy complement z plus x complement y complement z. Now check whether there is any duplicate term. Yes, we are having here one and here one. So discard one duplicate term and write the final expression, which is xyz plus xyz complement plus xy complement z plus xy complement z complement plus x complement y complement z. Okay, this comes as the sum of products form. Now we have to write its min-term designation. Since here these are original term, which means they are holding 1 1 1. So triple 1 is the binary equivalent to 7. So I write lowercase m subscript 7. So 1 1 0, it is the binary equivalent for 6, 1 0 1 for 5, 1 0 0 for 4, 0 0 1 for 1. Okay, then we write the final Boolean function of x y z equals summation of, so write it in the ascending order, 1 4 5 6 7. Okay. In case students you find difficulty on how to get these min-term decimal equivalent for it, then you have to completely refer to the truth table which I have explained in the previous videos for min-terms and max terms, through which you can get what are the min-term or max term designation for the given terms. So this is how we get the canonical expression. Under canonical expression we have two types. Then under those two types we have now today seen sum of products form, how to get a canonical sum of product forms with two examples. Okay. So children, I hope you are clear with this. Based on this video, you will be receiving again the assignment. So carefully go through the videos and solve the assignments. Thank you.